Hello, welcome to another video. In this video, I want to continue on the topic of building the Raspberry Pi camera stack and software from source on the latest Raspbian OS 12, which is codenamed Bookworm, on my Raspberry Pi 5. This Raspberry Pi 5 has two camera slots, CSI camera slots, and currently I have the Raspberry Pi camera module version 3, which is based on the Sony IMX708 sensor, and the Raspberry Pi AI camera module, which is based on the Sony IMX500 sensor. As a result, there is some additional support that I would want to have in the camera apps. In the previous video, I showed how to build the libcamera stack itself. In this video, I'll focus on building the camera apps, the rpicam-apps on the Raspberry Pi 5 under Bookworm. These camera applications from Raspberry Pi were named libcamera apps in the previous version of the OS. In Bookworm, they have been renamed rpicam-apps, and I will be following the recipe that is provided by their guides. Here's the guide from Raspberry Pi. This is under their documentation, raspberrypi.com, documentation, computers, camera software. And then this is under the advanced rpicam apps, how to build the camera, libcamera, and rpicam apps. So the first step is to remove, as they're suggesting, remove the previous cam apps. And so this is the system information. And currently, rpicam hello version that is installed from the apt package or pre-installed is version that was built from this commit hash. I'm going to remove it by pasting this command and in preparation for building it from source and installing it from source. And then I'm going to install some packages that are required. And this long list of packages that I'm going to install, these are just for building libcamera. But now these are the build dependencies for building the rpicam apps. I'm going to put this list of packages in the video description. So because I have a Sony IMX500 in the sensor in the AI camera, in the Raspberry Pi AI camera module, I want to build the rpicam apps with support for the IMX500. And one of the features of the rpicam apps is that it can do post-processing, and it can do post-processing of images that come from the AI camera. All right, next, I want to install some packages that are for this camera, the Raspberry Pi AI camera using the Sony IMX500. And as you see here, this camera can do it has an AI accelerator on board. It has a small image processor that can feed the images from the sensor to the AI accelerator, and it'll output a additional tensor along with the image data from the actual sensor going to the image sense, the ISP on the Raspberry Pi 5. So rpicam apps can take both the image data and the output tensor from the AI accelerator and process them and combine them, for example, by detecting objects. This AI accelerator can do object detection, pose detection, various tasks that a AI model can perform and provide that additional output tensor. And this the rpicam apps running on the processor can combine these two data paths and present them as a combined image on the screen. So there are some additional support that I can build into the rpicam apps for that. In order to accomplish that, I have to install this package imx500-all, and I'll have it installed with apt. As part of the packages that were installed, there's also some rpicam-apps-imx500 post-processing that are installed. So these with rpicam-apps, additional post-processing framework is available that it can do post-processing on the images. It has some built-in post-processing, and it can also use OpenCV. It can use Halo. It can use TensorFlow Lite, and it's also the framework allows it writing post-processing stages. So I'm going to have it install this additional package called Halo All. And the reason I want to do that, at the moment, I don't have this particular sensor in my system, but I may down the line want to either put an AI kit, which is this hat. This is the Raspberry Pi M.2 hat with a Halo AI accelerator, or that was with the kit, or this AI hat plus, which is just a hardware on top, and it's got this doesn't have an M.2 style accelerator. The Halo accelerator is soldered on the hat. So that's and it's actually comes in two variants that could be one variant that could be faster than the one that's on the AI kit. These are some of the things that I may want to play with. So I want to build rpicam apps with support for the Halo neural network model and framework. So basically, just installing this will satisfy the dependencies that rpicam would need. There's also some additional Halo post-processing packages that will get installed as a result. So in the previous video, I did build the libcamera. So we're basically here at this this stage. In order to build this, some additional tools are needed, and this list is already, you've seen that flyby, and it'll use the Meson and Ninja build system. This is the URL for where the rpicam source code is. I'm going to clone that, but before doing the rpicam apps, I'm going to update the libepoxy as well. So this brings another requirement for another package. But in order to build libepoxy from source, it should not be necessary, but I might as well build it from scratch. I'm going to create a directory for cloning the libepoxy, and then I'm going to go to that directory and clone libepoxy from the repo there. I'm going to go to that directory, and I'm going to make a underscore build directory here and change to that directory, meson setup. So this will configure the build, and then I will say Ninja. And Ninja will build the libepoxy. Okay, now that that's built, I will use Ninja to install libepoxy. Okay, so to build the rpicam-apps, I will create a directory where I will clone rpicam-apps from the Raspberry Pi repository. I will change into that directory. And then once I'm in the Raspberry Pi source directory, I will clone the rpicam-apps from the repo. Next, I will go to the rpicam-apps directory, and here I will paste this command, and I'll go through it to describe it. So it's going to be a meson setup build, and there are several flags that I will enable. First of all, the neon flags, I will set them for ARM64. Because I'm running on Arch64, the 64-bit Raspbian OS, I'm going to enable neon flags accordingly. If I was doing this under bookworm in on a Raspberry Pi 4, I would enable a different flag, which would be I believe it's neon dash ARM v8. So depending on whether you're running, because normally the Raspberry Pi 4, I guess it would be running under 32-bit OS. That's the flag. So they're different flags. But in my case, I'm running my Raspberry Pi 5 on 64-bit OS and 64-bit kernel. So then I'm enabling the enable libav, it's enabled, enable DRM, it's enabled, enable EGL, I've enabled it, enable Qt, enabled, enable OpenCV, I want to be able to do open post-processing using rpicam-apps using OpenCV. That's enabled. I don't have TensorFlow Lite installed, so I've disabled that. Down the line, I may have to enable this, but installing TensorFlow Lite on Raspberry Pi 5 under bookworm is a bit tricky. I have not found a way yet to do it, so down the line I may find it. But for now, since I do have a AI camera, I am enabling IMX500 is true, and I'm saying download the IMX500 models is true, and I'm also enabling Halo in anticipation that I will be adding either an AI kit or an AI hat plus to this Raspberry Pi 5. So I'm saying enable Halo equals enabled, and download Halo models is true. Okay, so I'll let Meson go and figure this out, and as you see, Meson was able to check all the requirements, and yes, it's enabling everything except the TensorFlow Lite. So then to get the build going, I say meson compile dash capital C to install the software that just got built, and it's going to install it. As you can see from this build directory, it's going to install it in user local share, user local include, and user local lib, and user local bin. Okay, so then one last thing is to say ld config. Okay, so now that it's built, let's try some of these different application different options for things that it can do. For example, let's try, let's go to the post-processing that can be done with it. One of the ways it can post-process is using the IMX 500's post-processing. Okay, so the IMX 500 post-processings are okay. So post-processing with rpicam-apps. Negate is a post-processing stage that is native. It's built in to rpicam. So you can, for example, say rpicam hello post-process file negate.json. And when it cannot, oh, okay, it needs the full path. So the full path is user share rpicam assets. Okay, so I have to say user share rpicam assets negate.json. Then it'll be able to find that post-processing, and what you see, it has inverted every pixel in the image. If I don't tell it to post-process, this is what the image looks like in actual colors. But then if I post-process it, you can see that it's inverted. And I can do this post-processing on images from either camera. So for example, I can say -- camera 0. Okay. And that's the camera by default it was using. But I can change that to be camera 1. And it's the other camera. So the image is slightly different. They're both looking at the ceiling. So rpicam hello -- list will show you that I have two cameras. The first camera 0 is the AI camera with IMX 500 sensor. Camera 1 is the camera module 3, Sony Raspberry Pi camera module 3. It has an IMX 708 sensor. So, but if I were to use the IMX 500, I can use some of the post-processing that is available for that. So you see, for example, it can do PoseNet, so it can do pose, or it can do object detection. So these will be done on the AI accelerator that is on the actual module. And then rpicam-apps will post-process it to stitch them together because it gets that additional information from the AI camera. So let's try that. Let's see. Post-process is IMX 500. Camera user share rpi camera assets IMX 500 mobile net. Okay, and I'm using camera. So if I were to let's see, I guess I should say -T0. Oh, this was camera 1. So camera 1 is not an AI camera. Camera 1 is a camera module 3. Let me say -T0 so it won't quit it before I'm ready. So this camera doesn't have, camera 1 doesn't have the AI sensor. So if I put my hand or anything above it, nothing will happen. No difference will be seen. But if I switch to the camera 0, which is the AI camera, it can run this on model on the ISP. And that the image is coming, as you can see, it's able to detect my hand and put a bounding box, put like a person. Okay, so this is saying, oh, there's a person there. Probability is 77%. Okay. So that was an example of a post-processing using the, the AI cameras onboard accelerator. rpicam-apps assets. There is this Sobel CV. So Sobel CV is a OpenCV Sobel edge detection. So what it will do, it'll detect edges in the image. So as you can see, it's applying the Sobel edge detection algorithm through OpenCV, and it's doing it at post-processing. So again, because this is OpenCV, this should work for both the camera that has the AI accelerator and the camera that doesn't. So I'm going to just switch to camera module 3, and yeah, it can do edge detection post-processing. Okay, so I wanted to see what else is there as far as assets. Motion detect. I think motion detect. Oh, annotate. Okay, so let's say annotate. I believe that's another OpenCV. Yeah, I think the ones that end with _CV are OpenCV post-processing. So here, as you can see that the image is being annotated at post-processing time by using OpenCV's annotation. I hope this video is useful, and hope to see you in another video.